Why do we need the SNR test bench? We use the SNR test bench to measure Ethernet data rates between two power line communication PLC adapters under various conditions. The data rate for both TCP and UDP traffic and PHY rates is measured at various signal strengths or SNR values. We make data rate measurements at various signal strengths by changing the attenuation of the data path between adapters. Then we change the type of line noise or impairment and take the measurements again. The Chariot test program also uses this test bench, but it measures data rate versus bit loss at a constant signal strength or SNR value. All these results are then reported in the adapter performance report. We'll see an example of this later in this presentation. First, let's look at the test bench components, then the type of tests we can perform, and then a short video clip of the ping stop test. Here we are on the test bench. Let's get started by looking at some of the components of the SNR bench. Two computers, one for the device under test and one for the golden node, execute batch program files that generate the data we collect. Mixer boxes, the silver boxes located here and here, combine Gaussian noise and our signals before and after the attenuator. The Gaussian generator, located here, generates a noise floor for the test bench. The SNR test bench measures data rates at various signal attenuation levels from 0 up beyond 70 decibels. The same bench will then collect data loss using the Chariot software tool, but at constant signal level. Two other benches, including the Smart Bits bench and Multi-NIC bench, will be described later. These are similar benches but collect other types of data not related to attenuation. This is the left-hand side of the test bench, or the DUT side. We will plug the DUT, device under test, into the 3093 mixer box and connect its Ethernet cable to the PC. To the right-hand side is the manual attenuator on top, located here, which will connect the two 3093 boxes together. Below the manual attenuator is the automatic attenuator, located here. We always plug the DUT into receptacle 2, or R2, shown here. The automatic attenuator is used in every production test station, or PTS. We'll describe that station a little later in this video. The manual attenuator, located here, and the automatic attenuator are used for the ping stop test and to measure the data rate versus signal attenuation. The manual or automatic attenuator can be used to change the signal's SNR ratio for the various tests. We'll use the manual attenuator during this demonstration. The automatic attenuator is used when automatic data collection processes are taking place. Automated data collection, introduced in the 2007 timeframe, is a significant boost to productivity. The automatic attenuator is controlled by this RS-232 connection located on the right side. That serial communications cable is connected to the DUT PC. Here is the golden node mixer box. Before plugging in the PLC module, again we always use receptacle 2, R2, to plug the module in. Receptacle 1 is used to plug in the SCR controlled halogen lamp or the compact fluorescent lamp that provides line impairments. Another impairment could be plugged into R3, but these are special tests. Clean isolated 110 volt or 220 volt power is required for both the DUT side and the golden node side of the bench. Here we see the shielded isolation transformer for the golden node side. A Sony Tektronix arbitrary waveform generator with two output channels provides noise to both the DUT side and the golden node side of the test bench. Now let's take a look at the short video clip.
Here we are on the signal to noise ratio bench, SNR bench 1, to demonstrate the first test we perform on all modules. The test is the ping stop test. The test measures the amount of attenuation necessary to stop the ping acknowledgement. On the left hand side we see the DUT, the device under test. The DUT is plugged into the 3093 mixer box. The mixer box mixes a small amount of noise brought in through this cable into the home plug signal. This coax then takes that signal plus the noise over to the manual attenuator located here. The manual attenuator provides the amount of attenuation from 0 to 120 decibels. The attenuation output is driven on this cable and is taken over to the Golden Node's 3093 mixer box. Again, small amount of noise is brought in through this cable and mixed with the signal coming from the attenuator. Okay, let's get started with the test by starting the ping program. We'll go to our shortcut and move our shortcut up to that part of the screen so you can see it. We're right now at about 40 decibels and our delay time is around 2 milliseconds. Now let's crank in some attenuation. There's 40, there's 50 decibels. We saw a little jump in the delay time. There's 51, 52, 53 dB of attenuation, and you'll notice that our times are starting to stretch out a little bit. 54 decibels. Times are stretching out 5, 7, 8, 9 milliseconds, but the module's recovering. 55 decibels. Now we're out to 139, but again the module is trying to compensate for the high attenuation. 56. Okay, looks like 56 is about it. 56 caused us to see a timeout. So in other words, our ping is not being acknowledged by the golden node. Let's crank it back down a little bit here to bring the ping back. Now we're at 54 dB. 54 dB, I see 4 milliseconds. 55 decibels. We're back up to some higher delays. 56 decibels. And again, we'll wait for a second here to see if the module recovers. But we're getting a request timeout, meaning that our ping stop number is about 56 decibels. We don't get a ping at 56 decibel. If I rock it back to 55 dB, we'll see that yes, there again fairly long delay times, but in fact we are receiving 55 dB. 56 is our ping stop. Okay, so the module will not recover after the ping stop point is reached. So our ping stop number that we would write on the report is 56 dB. This is not very good, but it is acceptable. Some of our modules, in fact, have the RD6300 golden node. Ping stop is over 60 decibels. After extensive testing of error rates and other tests, we can then call those modules golden nodes. The module we're looking at here is not a golden node. We'll crank back here to 54, 53, 52, and we can see our ping response comes back. 53 dB, 54 dB, and we're still, so 56 dB is a good number.